What's up, YouTube? Today I'd like to share with you an idea that I've had for quite a while but never got around to testing it. Now, I came up with this idea when I was in college and taking physics classes. In one of those physics classes, we did the we calculated the forces of a wheel on a boat in water. So, here's our boat and our wheel, and this is our shaft of our motor. So, to make it simple, let's say the water is about halfway up the boat and directly through the center of the wheel. Okay, so now the easiest way to do this is when the wheel is rotating in this direction, there is a certain amount of force applied to the wheel from the shaft in this direction. Now this portion of the wheel is moving through air, so there's very little friction and it can move with very little force. However, on the other side, there is water and there's friction due to the water. Now this requires a much larger force to move the wheel at the same speed. Alright, makes sense? But what we have here is an imbalance of forces on the shaft of this wheel. The shaft goes to the motor is connected to the boat, etc. But so there is a requirement for more torque on this side of the wheel than there is for on this side of the wheel. And that is basically what causes the boat to move forward, because to balance out these forces, there is also a force on the shaft. Now this force on the shaft is what moves the boat forward. By slowing down only one side of the wheel, we can move our entire apparatus forward. Now you might think, well, yeah, that's kind of straightforward and simple, but what good is that? We already know that works. Okay, but what if we change the scenario? Suppose our boat and our wheel is in space. There's nothing to slow down one side of the wheel. So how do we move? Well, I'll show you. So we have no water, we have a wheel, but let's change our wheel. So let's suppose our wheel is now made out of a very good insulator, say plastic or glass. And along the edge of our wheel, we add some conductors. Now, when we do this, you would probably do a better job than I'm drawing it, but maybe make them something like this as well. Kind of pretty similar to a Wimshurst machine. In fact, you could probably test this idea with a Wimshurst machine, but anyway, one of the discs of a Wimshurst. But anyway, so we have metal discs, we have an insulating disc with a bunch of conductors spread around it unevenly. If we spin it, it's still not going to do anything. But, so I'm going to draw a dotted line here to indicate, one half of the disc and the other where the water used to be. So we don't have water, we don't have air, we don't have anything to slow down this side of the disc to give us that differential in forces to move our boat forward. But what we can do, and this is very easily, is we can have a contactor, so like a brush contactor, touch each disc as it passes by and apply a very negative HV, electrostatic charge, to each disc as it goes by. Now, what does that do? Well, it adds a bunch of electrons to each disc, which technically increases the mass of each disc as it goes by. Well, okay, so what if we have another contactor here that is very, very, very positive? Well, then we're taking away all the electrons. So basically what we're doing is we're adding mass to this side of the disk and taking away mass from this side of the disk. So that would create a difference in forces. So we would have a small force up here to rotate the disk and a larger force down here. So this, in theory, would move our boat forward and give us a non-reactionary force in space. It could be, a space drive, and it would actually work better in space than it would work in the atmosphere of a planet, because in space you're not losing charge to air molecules. And there's also less friction. You could spin this disk a lot faster in space and generate a lot more force. But it's not only the mass that slows down a charged object. So we add mass, increases the inertia, it requires more force to rotate only on this side of the wheel. So we can call that the force of E mass. Now, according to electromagnetics and quantum physics, the electromagnetic mass is not the only force that we would have here. So since these electrons are accelerating around a disk, they're undergoing angular acceleration. Now, electrons under acceleration will resist acceleration by generating electromagnetic fields. So we have a force resisting our wheel on this side only to generate an electromagnetic field. And there is also another force that the electrons have. It's called the electron self-retardation force. If you look it up, it's real. The electron will retard its own acceleration. So it will slow down even more as it accelerates across the disk. Now that's a lot of forces to work in our favor in this case, because the more we can slow down this side of the wheel, the larger the differential in forces will be, and therefore the larger force our spacecraft will move forward with. So you could say that the total force of our boat basically is equal to, well, not equal to, but in this case, but proportional to the voltage, and it's times the velocity of the electrons. So the bigger the wheel we can make it, the more force we'll generate. The faster we can spin the wheel, the more force we can generate. The higher the voltage we can charge it with, the more force we generate it. The more force we would have as thrust. So yeah, that's my idea. I can't think of any reason why it wouldn't work. If you know why this wouldn't work, as if there's some physics law I've missed, please let me know. But if I'm correct, and I'm pretty sure I'm correct in this, then we could build, a spacecraft and have like giant disks, and this could possibly generate more force than would a rocket thruster. And the big bonus of this is we're not losing any fuel, we're not losing ions, we're not an ion thruster that's constantly throwing away mass in order to get thrust. This is solely contained. There's no there's no, the only thing it requires is electrical current for the motor and electrical current for the high voltage generators, which is pretty cool. Anyways, if you have any thoughts or ideas, leave them down in the comment section, and thanks for watching. Have a nice day.